say int s is equal to 1, right? And say y less.
Can you switch off the lights, please?
So what the flags like?
And I don't know, printf done. So we do this. So if I run this, nothing happens, and I do so I break here, right? Break here by less, and then I say cloud PS, continue with on.
Okay.
I could have also broken here and then do this.
So can you do what you just did with registers and instruction pointers? Could you manually modify an instruction pointer to an address that you're previously aware of if it's getting...
I mean, could I do a set ERP?
Exactly, yeah.
Yeah, absolutely. But hold on, you can't just modify the instruction pointer and expect it to work because the rest must go along.
Right.
Once the instruction being executed, assume that the stack has been set up and so on.
Right.
But yeah, you can do that. I mean, that's what I did do here in this macro. If you look at this is the thing that prints out a backtrace for a thread whose state has been saved. Okay, so the thread has been saved in some struct that I've defined stack here. So I'm setting ESP, I'm restoring EBP, then I'm restoring EIP. Then I'm telling GDB based on those restored values of ESP, EBP, and EIP to print the backtrace, and then I'm setting them back to their saved values.
Okay.
So this allows me to use the GDB's backtrace facility to produce backtraces for a number of threads that have been suspended in in this case, the context switch routine of our OS.
Okay.
Okay, so we'll show gprof. So gprof is a very old, very primitive tool, and as we just discussed, there are more advanced tools such as more profile available, which do, however, require an additional kernel module that's being loaded. But what do these tools do? So they give you information about where is time spent in your program. And so one example that is that I had to deal with actually before I talk about this, just one brief example of where GDB also comes in useful. And this was where I had a student, I'm going to show you the email, so the email exchange with that student. Okay. So I recommended that the student look at attached GDB, okay, and she wrote, yes, yes, I did attach GDB to the processes that are getting stuck and could produce the backtrace. I attached GDB to 3 processes, and these are processes in the application, okay, and then this was the output. So she attached it to this, so in GDB you can also start it, you say attach and give a PID to attach to that process, and you can get a backtrace. What she found was that, so if she did a backtrace in that process, she got this. And again, this was processes that she thought were getting stuck in some ways. The program just didn't appear to make progress. It attached into this one, and she got this backtrace here. I mean, this is a Fortran program, by the way, where read was called, okay, and she attached it to this one, which is a Perl script, and this one called pp open, pfos, and wait. It was actually stuck in this way. So from that we knew that 2 processes, this was an ensemble of processes, okay. One calls another process, waits for it to complete, and somehow it just didn't finish, okay. Actually, we had to figure out why for research. And so GDB told us, well, this guy is waiting, wait pit, he knows the system call, it's waiting for some other process to complete. Fine. This process here is stuck in a read, okay, it's waiting for some input. Okay. But this process here that's stuck in some function. Okay, enorm, in this case, computes some norm of two vectors, in this case. So what we learned from this is that this process, in fact, was running, was computing, and in fact, the problem didn't turn out as she thought to be one with pipes and input and output and deadlock, but rather, in fact, it was a problem with one process just not finishing. Okay, and GDB tells you that. But you can also do, after you see this, you can say continue, and you can break again and look at the backtrace, continue, break again, look at backtrace. And if you do that a number of times, you see where the program is currently executing. And there you can get some impression of what it is doing if it's not finishing. So anyway, in this case, the program didn't finish, we used GDB. But here's another example where we use gprof. Okay, so the problem here is we're doing some data mining. We are working on an interesting project where we are trying to data mine large heap dumps. A heap dump is, let's say, think of a Java program. A Java program runs, and at some point it runs out of memory. A number of objects allocated on the heap, and there's some relationships between those objects. And we would like to look at it, we'd like to analyze it. And to do that, we treat it as a graph problem. So we take that heap dump, we transform it into a graph, and we mine that graph. Okay, I don't do this, Naren from our Krishnan students do that. And so the student wrote a program here, and part of the analysis is to compute for that graph the so-called dominator tree. Okay, the dominator relationship between two nodes in a graph means A dominates B. If all paths that go from any root of that graph to B, it goes through A. That's the definition of a dominator. And based on this relationship, you can transform a graph into a separate graph that whereby there's a connection between two nodes, whereby there's a path between two nodes if A dominates B, and that second one is a tree, hence the term dominator tree. So this program computes the dominator tree. And the program, so this is the program here, and it turns out this program ran on small heaps. Okay, so I'm running it on a small heap, it runs, it finishes just fine. So this is a heap with what, 2,800 nodes, and it ran in 0.003 seconds. Now, in this work, we're dealing with large heap dumps, such as this one here. And a large heap dump, it takes 15 seconds just to load in the data, and then it just runs and runs and runs and runs. In fact, it never finishes, okay, at least as far as we can see. I think we let it run one night, and it hadn't finished after 15 hours or so. So the question is, what's going on here? Okay, why is this large program not finishing? What is the problem? And it's a common observation. This is calculating DOM tree, and it's going to run forever. So it's a common observation in programs that oftentimes the execution time follows some kind of par-2 distribution, uneven distribution, whereby 80% of the time is spent in 20% of the program. And so the question is, what is this? Why it's spending its time? And this is where a profiler can come in handy. And so what